today. I would like to start by giving some context on the central concepts for Confluent Cloud. How is Confluent Cloud structured? We will be talking about the concept of an organization, an environment, and clusters, and also take a look at what types of Kafka clusters are actually available. Then we do a quick tour of the Confluent Cloud UI, just to make you familiar with the interface. And I might be able to highlight some of the cool features, in particular when you are just starting out with Confluent Cloud. There are a lot of features included that make it easy actually to get started with a new Kafka cluster. For example, you can auto-generate the config that you need for your producer, for example. We then take a quick look at monitoring. This really as a quick overview of what is available. And of course, since we are talking about managed Kafka services, a lot of the monitoring we've been covering so far, if you remember, we spent quite some time on sample monitoring stacks for the GMX metrics of the brokers and all other components. These, of course, are hidden in Confluent Cloud, but we provide an abstraction for that to give you key insights into your cluster. Chapter 4 will deal with restricting access. We'll be covering two parts. First is the control plane in Confluent Cloud. That is the part where you are able to create new users, create a new cluster, etc. And the second part relates then with data plane. That is, who is allowed to access data in which topic. And this should be fairly familiar, as we here rely also on the concept of ACLs, access control lists, to restrict access to data in topics. Chapter 5 deals with the hosted and managed Confluent Cloud schema registry. We talked about schema registry before. Fundamentally, everything we talked about is still valid when we look at kind of the delta between the offering on-prem and what is available in Confluent Cloud. Chapter 6 deals with the options that are available for automating your CI/CD pipeline with Confluent Cloud. And there are two major streams really. One is, of course, how can I automate the creation of clusters and users, etc. What is available there? And then kind of matching potentially what you have been doing internally when you think of creating topics, for example, which tooling is available there. And then finally, a quick look at what is available for SSO in Confluent Cloud. Here we are talking about the UI, the Confluent Cloud UI SSO setup. So let's get started with the key concepts of Confluent Cloud and the cluster types. The hierarchical structure in Confluent Cloud has 3 levels. The root is the organization. And the organization, being the root, of course, has the high-level operations tied to it. So here you would find your billing information, the link to support. This is where you configure your SSO, for example. And this is where you actually create service accounts. Service accounts will be kind of technical accounts that represent applications, for example, which will be very important later on if we talk about restricting access. Service accounts are technical users that you create inside of Confluent Cloud that represent the applications you create, and these are scoped to the organization level in Confluent Cloud. Now, an organization can have multiple environments, and an environment is fundamentally just a logical grouping of clusters. So you could think of creating environments per kind of domain inside of the organization, or if you think about the development, integration, and production environments, these could be set up with different environments inside of an organization as well. It's important to note that, of course, you can have multiple clusters inside of an environment. And if you think about schema registry as the managed schema registry in Confluent Cloud, these are linked to the environment. So there is, for all the clusters that are running inside of one environment, one managed schema registry available in Confluent Cloud. As a side note, since if you start a cluster, a Kafka cluster, it's a Kafka cluster. Of course, you can run your own schema registry if that is required due to, let's say, organizational specific requirements. You just connect it to the Kafka cluster that you have created. So one of those reasons would potentially be that you require private endpoints for your schema registry. At the moment, the schema registry that is managed by Confluent is only available via public access, meaning via the internet. So requests to that schema registry are routed through the internet. And then going back to the organizational hierarchy, the cluster level represents the actual clusters that you will be creating. So you think of a Kafka cluster or a KSQLDB cluster, etc. And here you see then the constructs that you know from your previous experience with Kafka. You have your topics, you have your ACLs, etc., your consumer groups that govern the behavior of the applications interacting with the cluster. Now, this is the hierarchical structure. And if we now look at what Kafka clusters are available, we have 3 types of clusters available in Confluent Cloud. There are basic, standard, and dedicated clusters. And you can think of them as targeted at different requirements from organizations. The, let's say, most powerful, most reliable one is the dedicated cluster on the right, which is designed for critical production workloads. You will see that, of course, the feature set of these different levels of clusters is very different. So, for example, just picking one of the options on the slides, if you require a cluster to be running in multiple availability zones, this is not available with basic clusters, only available with standard or dedicated clusters. You have the associated LCLs on the slides. One other point to highlight here is that dedicated clusters, as the name suggests, are really dedicated to you as a customer. You do not share the resources of the cluster with someone else. Basic and standard clusters are logical clusters where the physical cluster behind is shared between different logical Kafka clusters. So if you require, let's say, dedicated resources, then you are in the category of dedicated clusters. Of course, basic and standard have mechanisms in place to avoid any situation of noisy neighbors or something similar you might be thinking of. If we are talking about dedicated clusters, these clusters are based, or let me rephrase, dedicated clusters come in increments of Confluent Kafka units, so-called CKUs. So you start a dedicated cluster with one CKU, and that is associated with a certain kind of performance and throughput, let's say, profile. And if you require more resources, you can easily scale the dedicated cluster by simply increasing the number of CKUs associated with it. This brings us to, I think, a very important point. You see at the bottom of each of those columns here on the slide links to limits per cluster and partition, limits per cluster and partition, and here then the specification of the CKU, for example. I'm switching to a browser tab just to make sure if the screen does not update, please let me know. You see here the specification of a dedicated cluster and the properties that are associated, in this case per CKU, of ingress and egress and storage, etc., that are associated with one CKU. So a very helpful example is, I think, the number of partitions is limited per CKU. So, for example, if you require 15,000 partitions, for example, then you need to specify the number of CPUs accordingly to get a cluster that works with that throughput and these requirements. I would like to highlight that we have these per CKU properties, but also per partition limits. So very important, if you are designing applications and have requirements, always come back to these properties of the clusters and the kind of the boundaries in which they can be operated. Switching back to the slides. Let me see if I forgot something very important. Yes, this one I need to highlight. If you have requirements for private endpoints, so thinking about VPC peering a cluster or providing a private link, if you think of Azure, for example, these options are available for dedicated clusters only. So kind of assuming the background as a financial institution, I would assume that production workload would really live in this dedicated column. I'd like to continue a little bit on this topic of limits and features, etc. So I've opened the tab already related to the cluster types and the properties in it. So we saw the dedicated cluster and its properties. If you think of creating clusters for a use case, I highly recommend always cross-referencing your requirements with what is specified in the documentation, when it comes to cluster types, but also when it comes to the features that are supported for example, topic management, which parameters can actually be tuned in Confluent Cloud. What properties does schema registry support? And we will see examples throughout the presentation of where there are limits that you need to be aware of when using the platform. There are some examples. So if you think about what I mentioned earlier, service accounts being the technical users representing applications, there is a limit on the number of service accounts per organization. There's a number, a limit on the number of API keys per Kafka cluster, meaning API keys, the key and secret that allows you as a user to connect to that cluster. For all these different dimensions, there are limits in place just to ensure that the platform is always working as desired by our customers. All these limits are provided here in this link. And again, if you design applications, please cross-reference with the limits that are provided here. Now, it's very important to highlight this point at the top. Listed here are the standard limits that are in place if you just spin something up. If you have requirements that deviate from this, please reach out to either the sales team or myself, or if we are not available, to the support portal to talk about raising the limits. There are hard limits and there are soft limits, but in general we are able to make the use case that you have work inside of the cluster. We want, however, to avoid a situation where you, let's say, create an application and, let's say, are surprised by certain limits that are in place. So maybe two examples that are helpful. So for example, the number of schemas per schema registry is limited, and also the number of ACLs per cluster is limited. So you can think of customers migrating applications from on-premise, where there was a lot of control, basically full control over the specification of the cluster, to a managed service where certain limits are in place. So if you come with, let's say, 200,000 ACLs, and that violates the number of ACLs that can be provided in Confluent Cloud, we need to figure out how to make it work. And we want to do that proactively right from the get-go so that you have a smooth experience with the product. With that being said, let's move on to Confluent Cloud and take a look at the UI and a quick walkthrough. So I will switch to my Confluent Cloud account, and we'll just click through some of the major tabs that are important. What you see here is something that you most likely will not see if you create a new account to play with Confluent Cloud. We have here the option to take a look at Health Plus. If you remember, we a couple of weeks ago talked about Confluent Proactive Support. This has been rebranded as Health Plus, and this feature showed the key metrics from on-premise installations inside of Confluent Cloud. This is then available in this tab. You most likely will not have that in your Confluent Cloud organization. What you will have is, on a starting page, an overview of the environments that are created inside of the Confluent Cloud organization. Most likely when you start out, you don't have an environment in a cluster. Here in this demo account, we do have a lot of environments and a lot of clusters. Let's just take a look at one of those. You see here the environment called AWS, because all the clusters inside of it, I think, are running on AWS. There are, however, no such restrictions. And you see on the environment level already, we have the schema registry that is, as I said, linked to the environment. And if you see here, the individual clusters are represented by those say tabs, little planes, giving a first indication of what is inside of that cluster. You see here popping up the different types of clusters. We have here a basic cluster, a standard cluster, it's single zone located in EU West 2 in AWS. You get an indication of the number of partitions, topics, etc. And jumping in here, you get then access kind of to the properties of the cluster. You see an indication of throughput, consumption and production, storage, partitions and topics. And here you see also very helpful the limits popping up that are associated, for example, here with partitions. In a basic cluster, we can only have 2048 partitions. And you see how connectors and KSQLDB applications being managed connectors and managed KSQLDB associated with this cluster. Now, before we go through all the properties here linked to the cluster, I would like to step back a little bit and go to a higher level briefly to indicate some of the properties associated with the organization level, for example. So if you open the burger menu on the upper right corner, you will see the stuff that I mentioned earlier associated with the org level, being, for example, accounts that you can create here. The billing is linked to the organization, as well as other features that we're not covering today, but also very interesting. For example, the audit log feature that is available for Confluent Cloud, at the moment supporting events occurring inside of the Kafka cluster. And of course, as I said, the single sign-on can be configured on the organization level. We have links to documentation, and of course you want also the integration with support. So the integration between Confluent Cloud and Zendesk, which we use for our support portal, supports that you have one user for Confluent Cloud and Zendesk. At the moment, only if SSO is not activated for the organization, but this is something that will be coming. What you can also change on org level is, of course, the support plan and the tiers available for it. Now, I think let's get back to the properties of the cluster, kind of the Kafka level information. And I'm being logged out, that is beautiful. Let me just log in again. Okay. Let's start with just an overview of the topics that are available. This is a demo cluster, so we have a lot of topics in here. Picking one, let's say maybe we find an interesting one which actually has data going through. You can select it, see production and consumption, and actually have access here to the messages that are running through that topic. Now you might be asking, why do I have as a user access to the data that is running through the cluster? At the moment, the Confluent Cloud UI users are super users. This is very important. So all Confluent Cloud UI users are super users, and that means they have admin rights. We will see later that we have role-based access control for the Confluent Cloud UI, but the roles that are available only extend at the moment to the control plane and have levels associated with the organization, the environment, and the cluster. So if you have access to the UI, you are a super user that can either as an org admin access all clusters, as an environment admin access all clusters in an environment, and if you are just admin of one cluster, access the data and everything associated with that cluster that has been assigned to you. There is active work on extending the RBAC concept to the data plane, which then would allow additional roles in the control plane to, for example, represent someone who is an operator, can see the cluster, he or she can see the clusters, but is not able to see any data. And we're getting a little bit ahead of ourselves here, but this is a very important point with the UI user being a super user. And this also, of course, means if you think about creating a user for an application, you really should use the service accounts. These technical users, which by default have no access to anything, so you explicitly need to enable them to read data from a specific topic, which then, of course, is mapped to the topics that your application needs access to. You might recognize this design also when you think about the schema associated with the topic. From Control Center, the UI is very similar, so you should feel at home if you're familiar with Control Center. Just like to highlight this once more. I mentioned it earlier. This being a managed service, you have not full control over the properties. And it's a good example here, the topic, you don't have the ability to govern all the parameters associated in general in Kafka with the topic. The scope is limited, and the slides include a link to what are the parameters that can be changed. Now, since we had a look at the topics, it might be interesting to take a look at data flow. This gives an interesting view of what is going on inside of the cluster. You see here different consumers and producers that are loosely coupled via topics, producers, consumers, and you can select then based on what you're looking for, what is going on. Now, assuming I'm interested in what is going on with this page view topic, you can zoom in, see the associated throughput, and coming soon the schema and messages. And you can think of this as a first step in the direction of more features related to data governance. I think it popped up earlier, data lineage. This is something Confluent is investing a lot into to automate kind of the view of data lineage in general, data governance when relying on Kafka. So maybe we take a look at this. This is a KSQL DB application. It's a create stream as select application. And here, again, we can see, of course, the consumption, but actually also then jump into how are my consumers doing. And this brings us actually to an interesting point here. Let's take a look at what is available as information for the consumers in the UI. So The UI for the individual consumers here provides visibility into, for example, the consumer lag on the individual consumers that are running. So if you think about accessing a cluster, let's again use a service account for some application, it needs access to a topic. The access to individual Kafka clusters is governed by API keys. Think of it as, API key and secrets. Think of it as user and password to access the individual clusters. So if you have an application that requires access to a specific topic inside of a cluster, you have the service account and then associate API keys to that service account that give access to individual clusters and then grant access to the topic via ACLs that you know from standard Kafka to that service account. One thing that is, I think, very cool, in particular when you get started, is if you want to set up a client with the properties, with the proper configuration, I would say, you can easily do that via the UI here. It really guides you through the process, and in particular when you're starting out, you get the config, you can create API keys in secret, and then copy the config to your IDE, for example, to get started. I will highlight this again later, but you see here API key for the Kafka cluster and an API key for schema registry. These are two different things. So if you utilize the schema registry in Confluent Cloud, the client needs separate access credentials to interact with schema registry. We have the cluster settings. If that were a dedicated cluster, we would here be able to, for example, increase the number of CKUs associated with the cluster. And now, looking to the future, should you ever be in a position where you open a support case related to something going on in a cluster, it's of course crucial that you communicate to the support engineer the Kafka cluster you are interacting with. And what typically is then requested is the so-called logical Kafka cluster ID, the LKC, that you can find here in the UI under cluster settings, or in general, if you are navigating through the UI in the address space of the browser. So we covered the Kafka basics, I think. Let's take a look at other features that are available. KSQLDB. You can spin up KSQLDB applications inside of Confluent Cloud that are then linked to your Kafka cluster and then define applications based on it. It's, I think, a very interesting proposition where you can then actually write streaming applications that are running 24/7 and continuously transforming data, for example, simply writing a couple of lines of SQL code, and you actually, in this case, then don't have to care about managing the cluster underneath that is then executing the generated Kafka streams jobs that do the actual work. Right? You click a couple of buttons or you request a KSQLDB cluster via the Confluent Cloud CLI, which we'll be covering later, and then are able to manipulate the data that is available in Kafka and write back to another topic after you've completed the transformations. Again, the UI is very similar to what is available in Control Center. You are, starting with the editor, able to create either new persistent queries or simply just query the stream that is ongoing or the tables that have been created, giving you access to, let's go here first, to the streams that have been created, and you might be interested in what is this guy doing. You can look at what errors are occurring inside of that processing step. You can query the data that is running through. So very nice features. And now briefly going to the flow. I think that is also very helpful if you think about the kind of the data that runs through a KSQL job. You clearly see here what is the input data that it runs through the page views enriched application, which reads or which joins page view events with user data that is provided in a persistent table. Okay. Maybe one last look ahead in a way here to the CLI, which we'll be covering a little bit later. So we can create clusters, service accounts, ACLs, etc., all within the UI. But of course, you want to automate stuff. And the key way to do that with Confluent Cloud at the moment is the Confluent Cloud CLI. And provided here is a perfect little example of how to get started. This is a great example of if you are in a situation where you have requirements that put you into a position where you have to manage, for example, schema registry yourself, or you have to manage a connect cluster yourself because it needs to interact with systems that are running inside of your private network, for example. Then you can run these components yourself, self-host them, but the Kafka backend of them would be the cluster that you run in Confluent Cloud, and how to connect those components is kind of guided here in the specification. With that, I think we step through the UI. Let's go back to the slides and just check if I forgot something. Briefly going through the slides, covered this. The support I mentioned, clusters, use the topic list, overview, data lineage. I did not show that, I just talked about it. So data lineage is coming to Confluent Cloud, and I will keep you updated as soon as we go beyond preview for data lineage in Confluent Cloud. We haven't talked about that in the UI, so we can do that with this slide. So we talked about KSQLDB being available as managed service in Confluent Cloud. The same is true for connectors. So if you have the need to connect external systems, be it a database or anything else to Kafka, or provide data from a Kafka topic to an external system, the tool of choice in that area is Kafka Connect. And for certain use cases, the Confluent Cloud offers managed connectors, which fundamentally allows you to just start a connector and provide, for example, the data available in a certain topic to a S3 bucket, for example, or what else do we have here? An AWS Lambda sync. So connectors are available, and you just specify the configuration inside of either an API or the UI. Of course, the managed connectors have certain limitations when it comes to private networking requirements. So if you have a use case in mind, happy to talk through it and identify if that can be set up either with managed connectors or with just running a Kafka Connect cluster yourself connected to Confluent Cloud. Yeah, we have an example here of a connector setup. Maybe we take a look. So in this cluster, we have some so-called data generating connectors running that are great for testing. You can specify or you can select in this case from a list of schemas for which data is generated, and this is then the foundation for the example that we saw earlier in KSQLDB, for example, and these are then managed connectors. Okay. We talked extensively over KSQLDB. We looked at consumer groups. The lag is available in, we'll do this later when we talk about the metrics API. We talked about cluster settings, and we didn't have that in the UI. So if you have a dedicated cluster, we talked about them being scalable in terms of Confluent Kafka units, CKUs, and this here just gives an example of how you fairly easily can expand your cluster via the UI. Okay, this is something new, and this is nothing where we go into a lot of detail. It's just very valuable information, I think. So if you think of what we stepped through just in the UI, we had access to the data inside of the clusters, right? I was able to consume data from a topic inside of a cluster. Now, if you decide to make a cluster only available via private endpoints, and that could be VPC peering or a private link, then of course the UI is not able to connect to those clusters to then fill, for example, the information on what topics are available, how many partitions are inside of that cluster. And that is simply due to the fact that it cannot reach that cluster. It's only available within your local network. There is a, let's say, setup that can be installed to allow the request to reach the clusters, and this involves setting up a proxy solution that then routes the request from within your VPC to the required endpoint. If you have this requirement, there is the link, of course, at the bottom here in the documentation to set this up. But again, please reach out to either the sales team or myself to get more information so we can talk through the requirements to set this up. One quick look on the consumer and producer config that needs to be set up to connect to Confluent Cloud. We saw this earlier very briefly when I clicked on the Java properties to be created for a cluster. So the mechanism with which you connect to Confluent Cloud, the SASL mechanism is plain, and what you fundamentally provide here is an API key, which is the username, and then an API secret, which is the password, which then should usually be rotated frequently to avoid any stale credentials. And of course, the entire interaction between the clients and the clusters are SSL encrypted. Now, there are recommendations here related to the JVM that are important to be set for Java. And that is simply related to the fact that the resources in the cloud typically change IPs, and we need to ensure that the caching of the DNS entries inside of the JVM is actually matching the requirements of Confluent Cloud. So we're restricting here the time to live of the DNS cache, and we set the time to live for the negative caching to 0 to avoid any negative caching on the DNS entries. And then the second property important for consumers and producers This ensures that if the clients, the Kafka clients, get back a list of IPs for a certain DNS entry, that actually the clients step through all the returned IPs before they throw an error. Standard behavior is that they check the first, and then if that doesn't work, they throw an error. So to ensure that there's no mix-up and issue with multiple IPs that are associated with a DNS entry, this needs to be set. And then something that most likely will not concern you since you're on AWS, but it's interesting, I think, nonetheless. If you have clients interacting with Azure load balancers, to ensure that the TCP connections are not, let's say, incorrectly terminated by the load balancer and kept alive, we need to tune certain parameters of the OS as well as of the Liberty Kafka-based clients. So if you ever come into that situation, again, please reach out. I think it's interesting in general to know this. That brings us to monitoring. So I started by presenting the example that if you're running a Kafka cluster inside of Confluent Cloud, it's a managed Kafka cluster, and of course, a lot of the, you might say all of the operational burden really of making sure the cluster is running properly, monitoring the logs, monitoring the metrics, that is done by the team at Confluent, who is managing thousands of clusters. And that of course also means you don't have visibility into JMX metrics that your broker is generating. What we do offer is a metrics or so-called metrics API that provides you with a subset of the data that is available via the JMX metrics that allows you to gain visibility into, for example, what is the throughput associated with my cluster or with my topics. And this is really the focus of this chapter. If you think of monitoring, of kind of getting an overview of what is associated with my applications that are running, there is of course what we saw in the UI where you can connect really who is talking to a particular topic, what is the producer that is writing to that topic, what are the consumers that are associated with the topic, and that gives you then very easy and quick access to, for example, as we have seen, the consumer lag associated with the application. But this just as a side note before we talk about kind of the metrics that are available. Now, metrics API. The metrics API is a REST-based API that provides visibility into the metrics of your Kafka cluster, your connectors, your KCQDB cluster, and also schema registry. And as always, I recommend that you take a look at the specification of the API that really goes into details of how to interact with the API. Pagination is supported. The query model is outlined here in much detail. And just to make sure you pick the right version, if you are searching on the internet, there may be examples out there still with version 1 of the metrics API. A couple of weeks ago, the version 2 of metrics API became GA. So if you start now building something, please use the version 2 of the metrics API. So typical use case for the metrics API would of course be kind of visibility into how many partitions do I have in my cluster, what is the throughput on the topic, etc. Now, there are two big questions really related to the metrics API. The first is how and how do I get access, who has access, and then how do I include this information in my existing monitoring stack? And this is what the next two slides are about. So we talked about the concept of API keys already in the context of Kafka clusters. So a Kafka API key and secret give access to a cluster, and with the associated ACLs give access to the data in the topic. Now, to read the metrics API, we utilize so-called cloud API keys. And additional to that, we have a control plane role that is the metrics viewer. We will see that later. That can be then associated with a service account that is then able to read the data from the metrics API. Now, one of the key parameters and metrics that are available for consumers is, of course, the consumer lag. Very important in the context of real-time applications. Is my consumer keeping up with the data that is produced? At the moment, consumer lag is not included in metrics API, and there is no endpoint directly available at the moment for Confluent Cloud where you easily tap that into your existing monitoring stack. In the last office hours, I already talked about the options that are available. We are not covering this today, but again, if you have additional questions, please reach out and we can go into more details. I've shared with Jack, based on the office hours, the options that are available for obtaining the consumer lag. This is a topic that is under active development, and it will come to the metrics API and the REST APIs that are coming for Confluent Cloud, but I'm not able to share in a timeline at the moment. What is very helpful if you're starting out with the metrics API is, of course, a collection of examples. So we have here this animated GIF that shows the interaction. I'm not going to step through this with you here today. I will share the link to the Insomnia specification. Just going back briefly, the animation here shows Insomnia, which is a tool to test REST APIs, similar to Postman, for example, and available in this GitHub repository are examples for Insomnia with the metrics API to get you started. Simply import it into Insomnia as which is available as an open source tool. In general, highly recommended this repo. It's maintained by one of my colleagues, and it contains numerous examples for connectors or, in general, anything Kafka related, being Kafka, Confluent Platform, as well as Confluent Cloud. And I will include the link in the email sending over the slides. So that would be a great starting point to get to know the API. Now, how can the interaction be automated? So available is only a REST endpoint, but you might be in a position where you want to include this into Prometheus, for example, in your monitoring stack. There is a very popular open source tool called the cCloud Exporter. It's an open source tool, and I have to stress this in such a presentation. This is not officially supported by Confluent, but it's been developed by a professional services colleague here at Confluent, which you can easily run inside of a Docker container, for example, which then reaches out to the metrics API to obtain the data regularly. It's scraping the endpoint, and then on the other side provides a Prometheus scrapable endpoint that you then use to integrate it into your environment. This tool is very popular, and more than 50, 60, 70% of the traffic to the metrics API is actually originating from this tool. So it's very popular, and a lot of people are using it. There are additional endpoints on the roadmap for the metrics API. That is a native Prometheus scrapable endpoint, as well as a direct integration with Datadog, for example. But at the moment, I cannot share when this will be available. So if you have a requirement in that direction, either be it Prometheus, Datadog, or any other monitoring tool, please share that requirement with me, and then we can loop in engineering to see when this will be available. Since the metrics API is a REST endpoint, we can of course use other ways of obtaining the data as well. An alternative solution or approach would be to utilize Kafka Connect, where you use a source connector against the REST API to obtain the data from the metrics API, store it in a Kafka topic, and then use a sync connector to deliver it to the tool of your choice, be it Datadog, AppDynamics, or the CloudWatch from AWS. Relevant links are on the slide, and this, if this is something you are thinking about, I think that is a great starting point. And that brings us to chapter 4, restricting access. When we talk about restricting access, there are two dimensions to keep in mind. I would begin again by repeating those. We always have to separate between control plane and data plane. Control plane, again, is creating a cluster, what you saw me do in the UI, create a user, create a cluster, etc. That is control plane. And then we have data plane, that is the interaction with the Kafka cluster. And there are different options available at the moment. And there's active development in that space. And with that, let's jump in. There is Confluent Cloud RBAC, but at the moment, the current version is limited to the control plane. I mentioned earlier that you have fundamentally 3 roles available. That is the organization admin, environment admin, and cloud cluster admin that are scoped to the Confluent Cloud organization, the A environment, an individual cluster. Within that scope, you have super user power if you are assigned one of those roles. So in general, rollback access control is something that is under active development, and this first iteration that has been published is the Confluent Cloud Control Plane RBAC, which gives you these roles that are on the slide. You have an additional one, the metrics viewer, that is used to obtain the metrics from the metrics API. Now, if you are assigned one of those roles as a user, you are a super user and have full access to the topics that are underneath. And just as an indication of what is available for the different roles, I think we covered that so far. Maybe we pick an example. If you think about the organization admin, this is the role at the root of the Confluent Cloud organization, billing, setting up the SSO, but also service accounts. Service accounts are linked to the organization admin, and then moving down the tree, environment admin is linked to a certain environment and has then no visibility into other environments that are available in Confluent Cloud. So if you think about the UI that I showed earlier, we have numerous environments. If I were just environment admin here, then of course I would only see those environments to which I've been assigned. And of course, then being limited to an environment, I would not have access here in the burger menu to, for example, setting up the SSO. Maybe this is a good example to see how it looks like if you create a new user and which roles you can assign. So included here is a link to a YouTube video. If we just look at the UI instead, we can do a proper example. So if I'm creating a new user, we provide an email address here and then can assign, and then can assign the respective roles to it. So potentially I can become admin on 2 clusters, but then have no visibility into anything else that is inside of the organization. Let me get to the next slide. So, now of course, having the super user access is of course not optimal. If you think about reducing the scope of individual users, that if they are compromised, can only do a limited amount of damage. So, as I said at the beginning, limit so far the number of users that are created inside of the UI, because they are all super users. If you think about it, giving access to an individual cluster to an individual user without giving them access to the UI, you can do that via API keys that can be scoped to a service account, which we'll come to in a second in more detail, or an individual user. But that user can then not, using the API key, rely on the cloud CLI, because that is linked to a user-based login and password. But you can use then this Kafka API key in combination with the standard Apache Kafka tooling to interact with the cluster. And ideally, we of course want to restrict the number of people that have the super user access to the Confluent Cloud UI. We will see an update to the roles available in the Confluent Cloud UI expected in the second half of this year to then extend RBAC to the data plane, and then based on that allowing additional roles in Confluent Cloud UI, where we then have users who are, for example, an operator which can just view the components that are running, but has no access to data and has not the ability to start new clusters or delete existing clusters. Now, I've mentioned before service accounts. One of the key concepts when you are running an application with Confluent Cloud. The biggest motivation really to use service accounts is that if you use a user-based concept, right? You have a super user and link API keys which give access to individual clusters to that super user, and this super user leaves the organization. You will be inclined to delete this user from your Confluent Cloud account, and that of course will trigger the deletion of all the associated keys, and that will then of course affect the applications that are running using these credentials. So if you are creating applications, really associate service accounts with the applications and then grant access to the clusters and the required topics via ACLs. So the service accounts can be created via the UI or via the CLI as indicated here on the example, where you create a new service account. If you plan to automate the process of updating, for example, API keys and service accounts, it's always helpful to use the description really to make sure you have kind of a second layer linking the service account to your application. And in terms of API key, always helpful to have again the link to the service account and the application, and potentially information on when this was created, so that you can avoid situations in a cycle where you rotate secrets, avoid deleting keys that are in use. Thinking of an application, you create a service account, but by default that service account has access to nothing. So we need to define the access to the service account, to the clusters for the individual. We need to associate with the service account access to the individual clusters, specifically the topics to which the application has access. There would be the access control list that also as a concept available for standard Kafka. Before we go to that, I would like to highlight one more kind of limit that is important. Looping back to our very early discussion about features and limits that are in place with Confluent Cloud, you have here a service account limit per cloud organization, which is 10,000. But to allow access for one of those service accounts to a cluster, you need to create an API key. And there are, maybe we go to the resource limits once more to drive home this point. There are API key limits associated with the organization, a generous 10,000, but also limits at lower scopes within the hierarchy, that being the clusters. So for a dedicated cluster, there's also a limit for the API keys, which is lower than the limit for the entire organization. So if you plan to, or if by mistake you create more API keys than are allowed per cluster, you just hit those limits, and I wanted to indicate there are different levels to the limits that are available. Okay, let's go back to the slides and to the ACLs, the access control lists. So the idea of the ACLs is to allow access to topics, and given that it's a standard Kafka concept, I don't think we need to spend too much time on it. I would like to highlight a couple of things, however. First is, of course, that the naming convention of your topics makes it often very easy to leverage then prefix ACLs, and this then helps with the ACL limits that are available. So typically we recommend to have this hierarchical structure in the naming conventions of your topics, which I am certainly already aware of. I just wanted to highlight it here once more, that leveraging the proper naming conventions for the topics would then allow to leverage prefix ACLs for the service accounts in the individual clusters. And again, I mentioned the example earlier today. If you are not relying on prefix ACLs and have an installation on-prem with a very large number of ACLs, these limits might require a rethinking in the design of the ACLs. And then API key and secrets, these are then the credentials that the service account or also the individual user needs to access the individual clusters. Again, they are created via either the UI or the CLI, which we will see in a second. Schema registry has a different set of credentials, a different set of API keys, which we will see in a second. And again, the mentioning here of the limits. You might ask yourself, why are we putting so much emphasis on the limits? We just want to avoid a situation where by mistake these are hit. And I myself have seen a situation where, for example, a lead in the CI/CD pipeline created with every deployment new API keys. And then, of course, you come into a situation where if you're not monitoring the number of keys that are created, you run into the limits and potentially run them into issues. That brings us to the end of restricting access. Maybe a quick summary. We have control and data plane. Data plane is access to the individual clusters. we use for application service accounts who get API keys to access the cluster, and we create ACLs to allow the service accounts access to individual topics in the cluster. A service account can be linked, of course, to different clusters, and by default, the service account has no ACLs. It doesn't have access to anything. And on the control plane, that is the UI, we have at the moment RBAC, role-based access control, with roles scoped to the organization, the environment, as well as the individual clusters. RBAC is under active development, and there we will see an update in the second half of the year to extend RBAC to the data plane. And then this will also then trigger a longer list of roles available for the control plane. That brings us to the managed Confluent Cloud Schema Registry. One of the first things that I showed in the UI was that if you come to the environment, let me go there. You have the schema registry at the environment level, and it's configured at the environment level. So within one environment, you have the schema registry to be shared between the clusters. In the UI, you can configure schema registry. The compatibility mode that we talked extensively in the schema registry enablement, etc., can be configured in the UI. And what is supported are the same serialization formats that are supported for on-premise, that is Avro, JSON, schema, as well as protobuf. The next slide highlights how to connect and some of the, let's say, features that you might expect but are not yet available in schema registry. The schema registry has a single endpoint, which is a public endpoint. So if you have, and I mentioned this before, private networking requirements for schema registry, i.e. no routing of the requests via the internet, then you cannot rely at the moment on managed schema registry. You would need to self-manage it by simply connecting a schema registry to the cluster that is running in Confluent Cloud. There is active development on extending the offering for schema registry. So if you have requirements in that space, please share them with us. Then we can loop back with estimates on when this will be available. There's a restriction on the number of schemas that can be published to the managed schema registry. I mentioned this very briefly in the schema registry enablement that we did previously. And we will have on the next slide then again the example of how to delete soft and hard schemas from the schema registry to ensure that you are under this limit. Crucially, the different versions of the schemas. So if you evolve the schema, for example, by adding an optional field, this counts as an additional version inside of the schema registry. The authentication for schema registry is based on a separate API key and secret that can be created by the UI or the CLI. Communication is encrypted, but crucially it's a separate API key and secret. We have the Kafka API key and secret and the schema registry API key and secret. And at the moment there is no access restriction for schema registry, meaning there's no RBAC for schema registry or ACLs for schema registry. This is again a feature on the roadmap. If you require this, please reach out and we can loop back on when this will be available. At the bottom, an example of how to connect. I think self-explanatory. Stressing once again, different API key and secret from the Kafka API key and secret. And then briefly, if you think about deletion of schemas in schema registry, we have hard and soft delete. Soft delete avoids or prohibits producers from writing new data with the schema, but continues to allow consumers to consume data that has been created using the schema. Soft deleted schemas count against the overall limit of schemas inside of the managed schema registry. And if you truly want to get rid of a schema, you need to use the parameter permanent true to then really delete the schema from schema registry to then reduce the count of the schemas in schema registry. That brings us to Confluent Cloud and CI/CD. How can I automate my pipelines when working with Confluent Cloud? The central tool for the automation is the cCloud CLI tool. We have a link here on the slide. There is very helpful auto-completion available for Dash and ZSH to, in particular if you're starting out, this is helpful to guide you through the commands that are available. You log in here with the Confluent Cloud UI and password, and this can be stored as indicated to then avoid having to enter it repeatedly. The Confluent Cloud CLI, as indicated here in the screenshot in the middle, gives you the option to create all the resources that we talked about so far. You can create user service accounts, create API keys for Kafka and for schema registry, spin up managed connectors, even consume data from a topic, create ACLs, etc., all from within the CLI. So it is the tool to build your automation around. And I would like to highlight the example that is running here on the screen. I won't step through it in detail, but it gives a great start to how to use the CLI to automate the creation of a cluster, for example, and then the subsequent creation of topics and service accounts with access to the topics. In general, very helpful resource here, the Confluent Inc. examples repository on GitHub that holds in this folder examples for Confluent Cloud, but in general numerous examples for all different components offered by Confluent Cloud. A definite bookmark for anyone working with Kafka and Confluent Cloud. Again, just another resource for starting out with the CLI. Similar to the example that was on the previous slide, just stepping through how can the Confluent Cloud CLI be used to automate all the activities around creating clusters and other resources in Confluent Cloud. Now, you might be thinking, aren't there other options available? And yes, there are, and there are additional options under development. So, of course, Confluent invests heavily in providing a REST API for all the operations that you might have for your Confluent Cloud account, be it the creation of a cluster, the creation of connectors, the creation of KSQLDB clusters. Everything should be and will be available via a REST API. However, at the moment, it is not yet available. It is available for managed connectors, for example, but not yet available for the creation of clusters and other resources in Confluent Cloud. If you are interested, there is a limited early preview for the REST interface that will be coming, but for the moment, the go-to tool for automating everything related to Confluent Cloud, in the sense of Confluent Cloud specific, is the Confluent Cloud CLI. If you think about the Kafka specific resources, a topic, for example. You can, of course, utilize here the standard Kafka tooling. For example, the standard Kafka CLI tools, as well as the Kafka admin client, which then talks to the individual clusters. Of course, if you use that route for the automation, that tooling is not able to create a cluster, for example. This has to be done by the CLI or the UI. If you think about creating your own REST API for the activities, you can, of course, use REST proxy, for example, to provide an interface for managing the Kafka-specific resources via REST API. But go-to in this space is still Confluent Cloud CLI. And if you now focus in on automating the creation of topics, for example, we have here on the slide the most prominent examples for the automation of the creation of topics, etc. That would be the GitOps approach that we, for example, shared in the office hours, I think last year. Tooling that I think will be familiar to you, be it what was previously called the Kafka Topology Builder, which is now called JuliOps, or Kafka Admin and Kafka DevOps, just as examples of what you can use. We have in here as well an example of how the Kafka Admin client can be used to create topics. And as I said, the Confluent Cloud REST API is in early access preview at the moment. If you have interest in joining this, please let me know. This would be an additional way of creating clusters and users, etc. And that is then the last slide for the automation, just to indicate kind of the steps in which the REST API becomes available. As I mentioned earlier, for managed connectors, the REST API is already GA. And this might give an indication also if you're looking for what will be available in the future. The style of the API, of course, will be very similar for the other Confluent Cloud resources. Last chapter, and we are not going into a lot of details here. I wanted to highlight this. Confluent Cloud, the UI supports SSO, so you can configure you can integrate Confluent Cloud UI with SSO, with your SSO provider. At the moment, this is not exclusive. This is something that I wanted to highlight. So even if you have SSO integration for Confluent Cloud, you are still able to have local users inside of the UI. The rest surrounding the SSO setup, fairly standard. You have your identity provider that is then linked to the control plane, and if you log in, then of course your login is forwarded to your identity provider. The request, however, has to be triggered from Confluent Cloud, from the Confluent Cloud side. I'm blanking, I'm sorry, on the technical term for this, but it needs to originate on the Confluent Cloud UI to log in. From a security perspective, let's say thinking beyond SSO and the RBAC that I mentioned, there is active work on bringing OAuth and OIDC to Confluent Cloud. This is under active development. If that is something that you are interested in, please let me know, and we can then, together with my colleagues from the account team, ensure that you are involved in this process and are, let's say, updated on what the engineering team is working on. The rest of the slides here just provide some background on the SSO setup and how it can be actually done together with the CLI, that this is also possible.